In this video, we're going to deploy 2 Docker images to a server and create a publicly accessible website. I'm going to use the same example as in the previous video, Docker Compose in 12 minutes. To quickly recap, we had a really tiny website written in PHP which just lists some products. The product information, however, is retrieved from the product service via a simple API call. The product service is written in Python and runs in a separate Docker container. So we've got the website there, which is just a bit of HTML, and it makes an API request to the product service, which runs in a different container. The product service is equally as simple, and it's this bit of Python here. When people hit the URL, we return some JSON, which is just an array of products. We also have a Docker Compose file which defines the 2 services. We've got the website at the bottom and then the product service above. It includes information about the Docker images, the volumes, and the ports that they run on. The code is available on GitHub if you need it, the link is in the description. To deploy these containers to the cloud, we're going to use Docker Cloud. This is a free service by Docker that will take Docker images and automate the deployment of them. The Docker images have to exist somewhere. This is called the repository. And then you need somewhere else to deploy them to, a server that containers will run on. Docker Cloud doesn't provide these things for you, it just sits in the middle and it automates the process from image in a repository to a running container on a server. Locally you have Docker Compose, which takes those images and uses the Docker Compose file to spin up your containers. Docker Cloud does a very similar thing, but in the cloud. Go ahead and sign up at cloud.docker.com. Once you verify your email address, you'll be able to log in. At the time of making this video, Docker Cloud has a swarm mode, which is in beta. If you want to follow along with this video, turn swarm mode off. Docker Cloud is made up of a few things. At the bottom in the infrastructure section, we have nodes. Nodes are servers that the containers will run on. Nodes can be put into clusters to group them together if you need that. On top of that, we have containers, the things that will run on the nodes. This view just lists running containers. You don't create them directly here. Instead, you can create a service. A service is an abstraction over a container. When you create one, you define an image that you want to run, you give it a name, and you can also specify other things like ports and environment variables. Much like when you use the docker run command in your terminal. And when you start a service, it'll spin up the Docker container in the background. Services make scaling really easy. If you want to scale, you tell Docker Cloud to increase the number of containers and it'll automatically spin up some more for you. The next thing you'll find in the sidebar are stacks. A stack is like a Docker Compose file. It lets you define services in a YAML file instead of creating them manually through the interface that we just saw. And this is useful if you've got an application like a website that is made up of multiple services. You can define them all in one stack file and then deploy that, as opposed to creating services individually and then trying to link them together. So we're not going to do anything in the services tab, we're just going to create a stack. And then the services will be created automatically. And finally, repositories. This is where Docker images live. Just like nodes, these are external to Docker Cloud. Docker has a repository service you can use. It's called Docker Hub. You can host one image for free. Any more costs $7 a month. You can also import images from external repositories. For example, I have some hosted on GitLab, but I'm not going to go into that in this video. Alright, let's start by creating a node. You can bring your own node as they describe it, which involves installing some software on server, whether that's a dedicated server or VPS or whatever is up to you, or you can use one of the integrations that they offer. So you see when you create one, you've got these providers to choose from and you can link your Docker Cloud account to one of these providers. So I'm going to use DigitalOcean. To connect the cloud provider, go to Cloud Settings, and you'll find the options here. You just need to click Connect Provider next to the one that you want to use. I was ready to give you my referral link for DigitalOcean, which I'll put in the description anyway, to get $10 free credit, but I've just noticed they give you $20 here, so fine, use that one. So I've just switched to a different Docker Cloud account because I already have my DigitalOcean account connected to this one. I'll create a new node though, go to Create. It'll actually create it as a cluster with just one node inside. Give it whatever name you want, it really doesn't matter. You can use labels. These are useful if you want to give it like a label of production and then deploy to all of the production clusters. None of these are useful for us though. And we can choose DigitalOcean. Depending on the provider, you'll get more settings. You can choose a region for DigitalOcean droplets, as they're called. And then you can choose which one you want. You will be charged for creating these VPSs with DigitalOcean, possibly with other providers as well. It's worth checking what the prices are before you do it. And if you put this up to 5, you'll be charged 5 times the amount. So it's really cheap, but don't go too crazy. So I can launch that, and what it'll do is, in DigitalOcean, create a new droplet, which is a VPS. And it'll create it with the right software and the right configuration, such that Docker Cloud can just throw containers at it and they'll run and magically work. So you never have to go to DigitalOcean to configure anything. You don't have to SSH into any servers. Docker Cloud will handle all of that for you. So it'll take a few minutes to deploy. While that is happening, let's look at repositories, because that's the other external thing that we need to link with. Since it's very well integrated with Docker Hub, since they're both services from Docker, let's use Docker Hub. You can create a repository in Docker Hub from the Docker Cloud interface, but I think it's a little bit clearer if we sign into Docker Hub and do it there. You can sign in with the same account as Docker Cloud. In Docker Hub, you have the choice between creating a repository or creating an automated build. A repository is something you can push a Docker image to. So you'd build the Docker image locally using the docker build command, and then you'd run a different command to push it to a repository in Docker Hub. An automated build will pull your code directly from GitHub or Bitbucket and build the image for you, which can be very convenient, so let's choose that. Of course, this means we need to push our code to Bitbucket or GitHub first. I'm going to use Bitbucket because it's free for private repositories. We also need to make sure we've got a suitable Docker file in each repository. So let's take a look at our code. We're going to create 2 repositories in Bitbucket, which will correspond to 2 automated builds in Docker Hub. We're going to have one for the product service and we're going to have one for the website. In the previous tutorial, we made a Docker file for the product service. It uses the Python image as the base image, and then it just copies our code inside. For the website, however, we didn't make a Docker file because we could just use the PHP image directly and mount a volume. This was great in development, but when you're deploying images to the cloud and trying to run containers on remote servers, mounting volumes isn't really a thing. Mounting a volume works in development because the code is on your computer and you can plug that straight into the Docker container when it's running. But this server we've got in DigitalOcean running our container, that doesn't have our code, so the volume mount doesn't make any sense. We need the code to be baked into the image. So just like the product service Docker file copies the code into the image, we need to do the same thing for the website. So I'm going to create a new file. This will be called Dockerfile inside of the website directory. All we need is from PHP with a tag Apache. That's what we were using before in the Docker Compose file. And we just need to copy the current directory into /var/www/html. As you can see, that is where we were mounting the volume to. The reason this one is the current directory with just a dot and this is /website is because the Docker Compose file is one directory higher than the Docker file. Now we don't need to do anything else, and we know that because this image worked directly without any modifications, and the only thing we want to change is we want that image but with our code already inside. So that should be enough to run the website. We can test this out locally in a terminal by going to the website directory. You can see we've got the Docker file there, and running docker build -t for the tag. I'll just call it example shop website, it doesn't really matter, and then a dot at the end to say use the Docker file in the current directory. Obviously make sure you've got Docker running first, and once that's done we can do docker run -p to set the port, so just the same as what we had in the Docker Compose file. We want port 5000 locally, mapped to port 80 inside of the container, and then the name of the image that we just built, which was example shop website. So if we go to localhost 5000, we can see that something loads. Now it doesn't work, it doesn't show the products because the product service is not running, so the API call that it tries to make just fails. But this is fine, this is what we would expect. What we wanted to know was, does the PHP application work at all? Does this Docker file do what we expect? And I think it does. It's loading and it's trying to make an API call to the product service, so that's good enough for me. Alright, next I'm going to go to Bitbucket. going to create a repository for the website. I'm just going to stick with example shop website. Make sure it's a private Git repository. So I need to make this website directory into a Git repository. You can do that with git init. And then we can copy and paste the commands from Bitbucket here to add the origin. If we do git status, we'll see that we have some untracked files. We can do git add dot to add them all. So now they are staged and ready to be committed, and we can do git commit -m to give it a message of initial commit. And then we can do the git push just like Bitbucket tells us to. Let me know if a git tutorial would be useful, and I can do that in the future. So if we refresh this page, we should see some different stuff. Go to source, we can see our files there. Great. Back in Docker Hub, we were mid creating an automated build. We can now choose Bitbucket. You'll have to link your account if you haven't already, it's really easy to do. And there's our example shop website repository in Bitbucket that we just created. So I'm going to make this private for now. Feel free to choose whatever visibility you want. Be aware that even though it's the image people will see on Docker Hub, you can just go and look inside of an image so you can see all of the code in there. So you are exposing everything if you make this public. If you've got no secrets or passwords or anything confidential in your code, then you're probably fine. I'm going to create that. The descriptions here don't matter because it's private, nobody else is going to see it. Build settings is an interesting tab. This is where you can make the build happen automatically when you push some code. So when you make some changes to your website and you push to Bitbucket, Docker Hub will see that change and rebuild the image, so the image is always up to date and you never have to worry about building it yourself. So you can choose a branch that when pushed to triggers the build. Master is the only branch that we've got. If you wanted to work on some different feature branches and have that build some different versions of the image, you could do that. You can have different Docker files and you can choose what tag that the resulting image gets. So when you see other images in the Docker Hub, and there are loads of different versions like PHP version 7, PHP version 5, PHP version 5 with Apache, this is how you'd set them up. You'd have a different Docker file for each one, and you'd tell Docker Hub to build them all when you push to master. The default settings are fine for us though, and we can try it out by clicking trigger. So this is what would happen if we pushed some new code. In build details, you'll see the new job is queued, and it's usually quite quick. Give it a few minutes and it'll start building your image. Alright, I left this for a while, it's finished building, it didn't actually take 4 hours. But it has worked, and now we can go back to Docker Cloud, and when we refresh, we see the new image available to use. So we need to follow the same process now for the other container that we want to ultimately run. So that would be the product service. This one already has a Docker file, it copies the files in, so that looks good to me. It's a case of creating another repository, initializing a Git repository inside the product directory, adding the remote, pushing to Bitbucket, creating a new automated build, so you can see if I try to make another private repository it won't let me. You can go and buy more for $7 a month. I'm just going to make this one public. I obviously wouldn't expect anybody to use this, but it is safe for me to put this online. There's nothing confidential inside of this image. So again, this one will build automatically when the repository is pushed to, but I'm just going to click trigger to make that easier. While we wait for that to build, let's take a look at stacks. We're going to create a new one, and like I said earlier, a stack is where you define all of your services that create your application. It's very similar to a Docker Compose file, so if we take a look at the Docker Compose file we have for this application, you can see we define services here, so we're going to be doing the same thing, but for the cloud. If you click the link at the bottom of the creation page, it will show you how stack files should look, and you can see it is like this section of the Docker Compose file. So you just skip the version and the services bit at the top and start directly with the service names. So using the Docker Compose file for reference, we can write our stack file. The first thing we need is the product service. And we're going to specify the image. It's really easy to refer to an image that's hosted with Docker Hub. It's just your username and then the name of the image that we created earlier. So it's example product service, and you can specify the tag. If you don't, it'll put it on automatically and assume you mean latest. That's the tag that it's got here. The next thing we can do is set restart to always. So if for whatever reason this service goes down, it'll detect this and automatically restart the containers, and hopefully things will be a bit more stable this way. We obviously don't need volumes because the code is already baked into the image, and we could specify ports if we wanted this to be publicly accessible, but we probably don't want the API to be accessible directly over the internet. We only want the website to be able to access the product service. So we're not going to specify any public-facing ports. Instead, we're going to go straight onto the website. Again, we specify the image. We're using 2 spaces for indents, by the way. So this one is example shop website. Again, the tag is just latest. So what we need here is to specify links. So this is an array of other services that it links to. With Docker Compose, this happens automatically. Everything in a Docker Compose file has access to each other. In a stack file, you need to be a bit more explicit about it. So we just need to say that it links to the product service. So that's just this name here, the name of the service. You can optionally specify an alias. So if you put a colon and then a different name here, that would be the name that the website service could use to refer to the product service. But if we look in the index.php file for the website, you can see that it makes a request to something called product service, so it needs to have that name. And if you don't specify an alias, it'll just use the service name as the alias. This one we do need to specify ports, or rather one port. We can make this available on port 80. So just map port 80 externally to port 80 inside of the container. And that's all we need. We should be able to create and deploy this stack now. If we go to timeline, we can see what it's doing. You get the console output as it's pulling the images and spinning up the containers. Once it's finished, you can go back to the general page and you get these endpoints. So if we had multiple containers that were publicly accessible, you might do this if you want to scale your service up and have multiple containers running the same thing. They would be listed here and the service endpoint would load balance between them. But for us, both of these endpoints are going to be the same thing. So if we click one of them, we see that the website works. It's on the internet. Anybody could access this. And this is happening in real time. It's making that API request to the other service, which is running in a different container. If we have a look at the containers section, we can see website 1 and product service 1 have been created automatically. Similarly, the services will have been created, product service and website. And we only have to worry about the stack. So we can see the whole application, both of the services that we need, the product service and the PHP website, are all encapsulated inside of this stack, and we can see the whole thing, the whole application is running. You can stop it, you can restart it, you can terminate it, which means stop it and then delete it, or you can go make changes if you want to. Obviously the endpoint, the URL we've got for this service is not very friendly. What you can do is go into DigitalOcean or wherever the server actually exists and find out the IP address of it. If we go to that IP address, you can see the website exists there. And you can use that IP address to set up DNS records for a domain name if you own one. I have a few websites running this way and I've got 6 containers running on one DigitalOcean VPS for $5 a month. And instead of exposing port 80 on each application, because that wouldn't really work if you've got multiple things that want to be on port 80, I have a proxy that sits in front of them. So I have another stack file here which uses HAProxy. Then it links to the services in other stacks that are running the websites that I want to make public. And this is the one that's exposed on port 80. The other services in their own stack files just have to specify the domain name that they want to sort of listen to, and when that domain name is linked to the IP address of the VPS, the droplet, it just magically works. So if you want to run multiple websites on one node, then look into proxies, specifically HAProxy, really easy to use. But that's pretty much how you would take your Docker images that you made locally and get them deployed to the actual internet and be publicly available. We're hosting our code in Bitbucket, but it could be in GitHub. We're using Docker Hub to build the images automatically when the code changes. Of course, you could skip this step and just push your pre-built images straight to a repository created on Docker Hub or another Docker registry that exists. Like I mentioned at the beginning of the video, GitLab offer something similar to Docker Hub. And then we're using Docker Cloud to take those images that exist and spin up containers and put them on a real VPS that exists on the internet. This is, of course, not the only way you can deploy Docker containers. There are many different techniques for orchestration and getting your containers running somewhere. But if you're building small applications, then this is a really easy way to get started. And like I said, this is how I run multiple websites, and they've been running for 9 months this way with no problems. I hope this was helpful. Good luck with your Docker applications and your deployment of them. I'll see you next time. Thanks for watching.